In this final lecture for Chapter 7, we will be examining how the use of sustainable agricultural practices can help protect soil resources and minimize use of pesticides, fertilizers, water, and petroleum products, and avoid the use of GMO crops. Sustainable agriculture is an important technique to reduce carbon emissions by reducing fossil fuel use and the use of fossil fuel byproducts, and by sequestering carbon in the soil. In this lecture, we will be describing some of the environmental costs of farming and how we can minimize these costs by the use of sustainable agricultural practices and sustainable consumer practices. We will also see how sustainable agriculture protects soil and helps to minimize carbon inputs to the atmosphere. Recent analysis of decades of crop monitoring data have found that sustainable farming techniques can provide comparable levels of productivity and economic gain for farmers compared to conventional monocropping, especially in developing countries. The goal of sustainable farming techniques is to ensure that farming is sustainable and equitable, which seeks to repair the environmental damage associated with industrial farming such as soil erosion, fertilizer contamination, formation of pesticide-resistant pests, and the use of expensive GMO crops. Many sustainable techniques are really just returning to the ways that we produced crops and livestock prior to the industrialization of agriculture. UN studies in Africa, for example, have found that sustainable techniques, including integrated pest management, intercropping, and crop rotation, can provide income and productivity as good as that of conventional techniques, but far more cheaply. Crops grown without synthetic fertilizers or pesticides produced, on average, about a 20% lower yield than similar crops grown by conventional methods. But they more than made up the difference with lower operating costs, premium crop prices, less ecological damage, and healthier farm families. For impoverished and hungry populations in developing areas, argues UN researcher Olivier de Schutter, it is foolish not to pursue all available options, including sustainable techniques. With careful husbandry, soil is a renewable resource that can be replenished and renewed indefinitely. Because agriculture is the area in which a soil is most essential and most often lost through agriculture offers the greatest potential for soil conservation and rebuilding. Among the most important elements in soil conservation are terracing, ground cover, and reduced tillage. Most erosion happens because water runs downhill. The faster it runs, the more soil it carries off the fields. Water runoff can be reduced by grass strips in waterways and by contour plowing, that is, plowing across the hill rather than up and down. Contour plowing is often combined with strip farming, the planting of different kinds of crops in alternating strips along the land contours. When one crop is harvested, the other is still present to protect the soil and keep water from running straight downhill. The ridges created by cultivation trap water, allowing it to seep into the soil rather than running off. Contour plowing and strip cropping help prevent soil erosion on hilly terrain, as well as create a beautiful landscape. Terracing involves shaping the land to create level shelves of earth to hold water and soil. The edges of the terrace are planted with soil-anchoring plant species. This is an expensive procedure, requiring either much hand labor or expensive machinery, but it makes farming of very steep hillsides possible. Annual row crops, such as corn or beans, generally cause the highest erosion rates because they leave soil bare for much of the year. Often, the easiest way to provide cover that protects soil from erosion is to leave crop residues on the land after harvest. They not only cover the surface to break the erosive effects of wind and water, but also reduce evaporation and soil temperature in hot climates, and protect ground organisms that help aerate and rebuild soil. In some experiments, crop residue increased water infiltration by 99% and reduced soil erosion by 98%. Often, soil is protected with cover crops like rye, alfalfa, or clover, which can be planted immediately after harvest to hold and protect the soil. These cover crops can be plowed under at planting time to add organic matter and nutrients to the soil. No-till planting involves drilling seeds through debris from last year's crop. Here, soybeans grow through corn mulch. Debris keeps weeds down, reduces wind and water erosion, and keeps moisture in the soil. In contrast to the trend towards industrialization and dependence on chemical fertilizers, pesticides, antibiotics, and artificial growth factors common in conventional agriculture, some farmers are going back to a more natural agroecological farming style. Finding that they can't or don't want to compete with factory farms, these folks are making money and staying in farming by returning to small-scale, low-input agriculture. On the Minar family's 230-acre dairy farm near New Prague, Minnesota, cows and calves spend the winter outdoors in the snow, bedding down on hay. Dave Minar is part of a growing counterculture that is seeking to keep farmers on the land and bring prosperity to rural areas. The Minar family, for instance, operates a highly successful 150-cow dairy operation on 97 hectares or 230 acres near New Prague, Minnesota. No synthetic chemicals are used on their farm. Cows are rotated every day between 45 pastures or paddocks to reduce erosion and maintain healthy grass. Even in the winter, livestock remains outdoors to avoid the spread of diseases common in confinement. Antibiotics are used only to fight diseases. Milk and meat from this operation are marketed through co-ops and a community-supported agricultural program. Sand Creek, which flows across the Minar land, has been shown to be cleaner when leaving the farm than when it enters. Since the 1960s, U.S. farm policy and agricultural research has focused on developing large-scale production methods that use fertilizer, pesticides, breeding, and genetic engineering to provide abundant, inexpensive grain, meat, and milk. As a consequence, we can afford to eat more calories and more meat than ever before. Hunger still plagues many regions, but increasing nutrition has reached most of the world's population, not just wealthy countries. We now worry about weight-associated illnesses as a cause of mortality, possibly a first in human history. Cheap food policies have raised production dramatically to feed growing populations both in the United States and abroad. Farm commodity prices have fallen so low that we now spend billions of dollars every year to support prices or repay farmers whose production expenses are greater than the value of their crops. The United States buys millions of tons of surplus food every year, often using it as food aid to famine-stricken regions. This social good is also problematic, as cheap or free food donations undermine small farmers in other countries who cannot compete with free or nearly free food on the local market. These policies are deeply entrenched in our way of life, politics, and food systems, but there may be some steps that consumers can take to support the beneficial changes in farming methods and farm policies while reducing their negative effects. A locavore is a person who consumes locally produced food. Supporting local farmers can have a variety of benefits, from keeping money in the local economy to ensuring a fresh and healthy diet. Maintaining a viable farm economy can also help slow the conversion of farmland into expanding suburban subdivisions. As many farmers point out, you don't need to eat 100% local. Converting just part of your shopping activity to locally produced goods can make a big difference to farmers. Farmers' markets are usually the easiest way to eat locally. The produce is fresh and profits go directly to the farmer who grows the crop. Pick Your Own farms also let you buy fresh fruit and other products, and they make a fun social outing. Many conventional grocery stores also now offer locally produced organic and pesticide-free foods. Buying these products may, or may not, cost a little more than non-organic and non-local produce, but they can be better for you and they can help keep farming and fresh local food in the community. Your local farmer's market is a good source of these locally grown organic produce. Because there is less energy involved in producing food from plants than producing it from animals, one way you can reduce your impact on the world's soil and water is to eat a little more grains, vegetables, and dairy, and a little less meat. This doesn't mean turning vegetarian, unless you choose to do so. Just returning to the level of protein and fat consumption your grandparents had could make a big difference for the environment and for your health. In summary, regenerative agricultural practices protect the soil and reduce the need for watering, pesticide use, and fertilizer use. Because less fossil fuel is used for vehicles, pumps, fertilizers, pesticides, and transportation, this also reduces the carbon footprint of farming. So, in summing up our lectures on food and agriculture, we see that food production has grown faster than the human population in recent decades, and the percentage of people facing chronic hunger has declined. Increases in food production result from many innovations in agricultural production, like the Green Revolution and the development of GMOs. These changes bring about environmental problems, such as soil erosion and water contamination from pesticide and fertilizer applications. Consumers can influence farm production by choosing what food they buy and where they buy it.